Okay, so this one we're going to look at transformations of functions. And so what this is talking about is if you have just say y equals x squared, or it could be any basic function, y equals x squared, x cubed, square root x, absolute value of x, e to the x, we'll see later. Um, any basic function like that. The graph of this particular one looks like that. Now, how do you move it around? How do you maybe move it down, or how do you flip it upside down and move it up? How do you, uh, let's say that's stretched up, so maybe it's thinner, or how do you spread it out? How do you do all these things? So maybe it looks more like that. So all of these are all the same basic form as this one. It's just it's been transformed in some way. So how do you do that? So very basic rules, and I guess technically you don't have to memorize these. There are ways to figure it out. You could always make a table, and if you have like x squared plus 2, just make a table and see what it looks like. But if you do memorize these basic rules, then those graphs will be a lot easier. So I do recommend you memorize these. But if we have just say x squared plus c, that would move up c units. Or if we have x squared minus c, that would move down. And I'm not going to write c units every time, but down c units, however many. So if it's x squared plus 2, up 2 units. If it's x squared plus 7, up 7 units, and so on. If we have x minus c squared, that is going to go right. Now you might think it's going to go left because on the x-axis, negative is to the left and positive is to the right. But it's precisely because of that it's the opposite here. Because if you want y to be 0, what does x need to be? X would need to be c, and so you'd have to move it right. So if you want to go from this to this, then and you call that C. Well, X is C here, where Y is 0, so it has to be C. So you moved it C units to the right. Whereas if you went over here, that would be negative C, and you plug a negative C, it'd be negative C plus C. So if you had X plus C, you'd be moving it to the left. Um, so like I just said, X plus C squared, you're moving it to the left. All right. What if we want to stretch it? So that would be putting it, and we'll use a this time. So a x squared. And in this case, kind of need to say is a if a is greater than 1, that stretches vertically. Um, so that means it's going to get thinner like that. Or if a is between 0 and 1, that stretches horizontally. So that means it's going to get wider like that. Um, what if a is negative? What if we have negative x squared? That's going to reflect over x. So be upside down like that. All right. What if we have what if we have a inside? So we have like ax squared like that. Well, it's going to do the opposite of what it does here. So if a is greater than 1, um, a is greater than 1, it's going to stretch horizontal. Or actually, we should say compress horizontally, which is kind of the same as vertically. It's going to get thinner like that. And then if A is between 0 and 1, in that case, it's going to compress vertically. Or maybe we should say, let's say this differently. Let's say, let's switch these two. Let's say compress vertically for this one. And let's say stretch horizontally. I got this backwards. Kind of do the same thing, but stretch horizontally. So it's going to get wider again like that. So it kind of depends on where it is. It depends on where the A is, I should say. And then what if we have y equals negative x squared? Well, in this case, it doesn't really do anything visually. It does do something, but it reflects over the y-axis, which in the case of x squared doesn't really do anything. But if you have, so let's say it's kind of rotating like that, whereas in this one it's rotating like that. So we're rotating around the y-axis. Now, if you have like an exponential function that does this and you rotate around the y-axis, then it's going to look like that. If you rotate over the x-axis, then it would look like that. So it can do stuff, and square root function is an example of that, where reflecting over the y would change it. If it's a function like this, it's already symmetric around the y-axis, so rotating around the y-axis doesn't really do anything. But in any case, the ideas that we're looking at are all these rules that can help us figure out what the transformation is doing. So let's look at an example. And so we have square root of x. And we're going to do these different transformations. So the first one, we have square root. Well, I guess before we do that, we should say what square root of x looks like. So y equals square root of x looks like that. If we have square root of x minus 2, the minus 2 is outside the square root, so that is a vertical move. And the minus means it is going to go down. So it is going to go down 2 like that. So you'd start at negative 2. If we have square root of x minus 2, and now the 2 is underneath the square root, so that is a horizontal move, and that is going to move to the right. So we know that y is 0 right there. When x is 2, that makes sense. 2 minus 2 is 0. Square root of 0 is 0, so y is 0. What about this one? Negative square root x. That one is going to, we have the negative outside here. It's going to flip it over the x-axis. And so it's going to look like that. And then the last one, y equals square root negative x. That, the negative now is inside. So now it's going to flip it around the y-axis. It looks like that. If you think about this one, I mean, that would make sense because the domain, what can you plug in for x? Well, whatever you plug in for x is going to be negative after that, or it's going to change signs, we should say. So if you plug in 2 for x, y is going to be the square root of negative 2, which doesn't work. We're only looking at real numbers. But if x is negative 2, now we have the square root of negative 2, or the square root of 2. So now y is a positive answer, which works. Whereas here, x can still be positive. In fact, it cannot be negative. And anything that you plug in, you take the square root and then you make it negative. So all the y values are going to be negative. That's why they're down here. All right, the last one. So we'll combine a couple of these. So y equals x squared, of course, looks like this. Now we have x plus 3 squared minus 1. And so let's talk about the transformations here. So we have a plus 3. That is going to go left 3. And then we have a -1. That is going to go down 1. All right. So let's go left 3. Let's go down 1. And there, so oops, that point there used to be here. So it used to look like that. Used to look like that. Now it's going to look like this. And we won't worry about the width or anything, but it's the same width as a standard x squared function. All right. Next we have the -1/3 x squared plus 2. So the 1/3, and this is outside the square, so that is, I guess we should technically say compresses vertically. It's gonna get wider like that. The negative in front is going to reflect over the x. So now it's going to be the upside down version of that. And then the +2 moves it up 2. So so maybe on this one, when you have multiple ones like these, especially with the reflecting and the moving vertically, um, let's kind of go step by step. So let's do the 1/3. So that I'm exaggerating this a little bit, but let's make it look like that. Then let's reflect over the x. So it's going to look like that. And then let's move it up 2. So it's going to look like that. So the order does matter, actually. And the way to remember it, or I guess not the way to remember it, but the thing to remember is that the vertical moves always come last. Beyond that, um, we would do these first and then the horizontal and then do the vertically, but the vertically always comes last. And usually it doesn't matter too much beyond that. But that is the graph that we end up with. All right. So there's your transformations. Again, if you memorize the rules, then these things are a lot easier because a lot of rules to remember, but a lot of them are fairly logical once you kind of get used to doing them. So if you have any questions, feel free to email me.